meters, and other electrical test tools should be independently evaluated to make sure they can survive high voltage transients. A special test machine is used to generate the overvoltage transient and fault current as defined by national and international standards. This meter is marked 1000 volts Cat 3 on the front of the case. More importantly, it has been certified by an independent testing laboratory. A 1000 volt Category 3 tester is required to survive a minimum of 10 transients of both positive and negative 8000 volts without creating a hazard. Fluke goes a step further in designing and building our test tools. We build our meters with safety in mind. In addition, we build them to survive. As a short test, we have programmed our test machine to increase the transient voltage in steps until the meter fails. 6,000 volts, 9,000 volts, 12,000 volts, 15,000 volts, 17,000 volts. This meter finally failed at about 17 kilovolts, which easily exceeded the minimum of 8 kilovolts. Some manufacturers state that their products are designed to meet or conform to standards, but not every meter or tester that makes that claim will pass the test. Here's what happened when one meter, marked 1000 volts Cat 3, was actually tested. The meter is supposed to withstand a minimum of 20 transients of 8 kilovolts each, but this meter failed twice before reaching the 8 kilovolt minimum level. If this had happened on a power circuit, the results could have been disastrous. How could this meter fail the test? The standards bodies only create the standards. They do not enforce them. A meter that claims to be designed to a standard may have never been tested to it. That's why it is essential that the tester you use is labeled to show it has been certified by 2 or more independent testing laboratories, such as UL in the United States, CSA in Canada, and TUV in Europe. This is the only way you can be sure your testers have passed the most rigorous tests and meet every applicable standard. Here's what can happen when a meter marked Cat 2 is used in a Cat 3 environment. In a real Cat 3 or Cat 4 environment, the arc would have been fueled by thousands of amps. The resulting arc flash could cause serious damage to people and equipment. In addition to the right kind of transient protection, a meter should be able to withstand accidental overloads associated with the various functions of the meter. This meter is marked 600 volt Cat 2. Watch what happened in this test when it was connected to a live circuit while in ohms. Here's what it does if you measure voltage using the amp's input jacks. The fuse would not protect the meter or user. Just imagine if this meter was in your hand and used on a real Cat 3 circuit. Even the most careful of us will make mistakes. That's why, if an inappropriate voltage is applied, your meter should offer a margin of protection. This principle is so important that it has been written into current safety standards. The standards require that test equipment must handle the full meter voltage rating in the ohms and continuity functions without becoming a hazard. To meet the demands of today's high-energy, high-hazard workplace, quality manufacturers have re-engineered their test instruments to make them more reliable and far safer.